So today's webinar is about methods to estimate the between study variance and to calculate uncertainty in the estimated overall effect size. I have no competing interests in relation to this presentation. So the objectives of this webinar are to give an overview of all the available methods to estimate the between study variance and its uncertainty, as well as an overview of the methods to calculate a confidence interval for the overall effect size. Then we will compare the methods using the findings of published real-life and simulation studies, and we will discuss the prediction interval calculation and potential issues associated with it. At this point, I would like to mention that this work has been conducted on behalf of the Cochrane Statistical Methods Group and that we have published 3 research articles on this. And of course, I would like to especially thank all my collaborators on this great effort and for their advice through all this time and their patience, of course, to conduct these studies. So let us consider the fictional example with 5 studies. The choice of the method to estimate the between study variance may give different results on the estimated value, and therefore this may impact on the estimation of the overall effect size and its uncertainty through the study-specific weights that are calculated under the random effects model. Similarly, the method to estimate uncertainty around the overall effect size may impact its interpretation. Therefore, in the meta-analysis, the choice of the method to estimate the between study variance and the confidence interval for the overall effect size is important, and especially when inappropriate methods are being used, such as imprecise or biased methods, which may jeopardize the meta-analysis findings and their interpretation. Before I move on, I would like to ask you whether you have a different other than the default option between study variance estimator, and maybe Dario can help me with the poll. Okay, so the majority of you use the default option in the relevant software, so that means actually that is what most people do. And also, since I'm a Cochrane statistical reviewer, I also encounter this very often in Cochrane reviews when I actually ask the reviewers, ask the authors, what is the option, what is the estimator that they used in their analysis, if they use the default option and why. So many people actually are not, many reviewers were not aware of the different methods and they just select the default option. But we'll see in the next few slides that there are cases that we need to be cautious about the selection of the estimator. So let's see an illustrative example by Thorland et al. That was published in 2011. So the authors included 7 studies comparing corticosteroids versus control for preventing death. And the authors applied different heterogeneity estimators. Now, as you can see, the estimation of heterogeneity may vary from 0% to approximately 87% when we use the d-square measure to measure heterogeneity. So this impacts on the pooled effect and mainly on its precision. So now the question is, which of these or any other is the most appropriate method to use in a meta-analysis? So at the first part of this presentation, we will discuss methods to infer on the between study variance. We conducted a lit review of the between study variance methods, and we identified 16 methods to estimate heterogeneity, and we were able to group them in 5 broad categories. We also identified 9 methods to calculate the uncertainty around the between study variance, and we also grouped those methods in 6 broader categories. So all these methods, the properties of these methods were evaluated in several simulation and real-life data studies that compared at least 2 methods. Now, to select the most appropriate method, we need to assess the properties of these identified methods. First, we need to consider whether an estimator can include the 0 value. So we have methods that can be categorized as positive and methods that can be categorized as non-negative. Then ideally we would like an unbiased estimator or an estimator with a very small negligible bias, and then we would also like to have a small mean squared error accounting for both bias and variability in the tau square and the heterogeneity. And when we have a small mean squared error, then we have an efficient estimator. Further, we would ideally select an easy-to-compute estimator. That is, we need to consider the number and complexity of steps to estimate heterogeneity and whether the method that we consider is direct or an iterative approach. Now, the method of moments estimators that we will see in the next few slides can be categorized to the Cochrane's Q-based methods using the fixed effects weights and the overall effect size estimated under the fixed effect model, and to the generalized Q-based methods using the generalized Q statistic and the random effects weights. So these can be, both statistics can be categorized to a broader category, the generalized Cochrane between study variance statistics, where we have AI, the study weights. Now, in general, a method of moments estimator can be derived by equating the expected value of the statistic QA to its observed value. So then we can get the generalized method of moments estimator that is a broad category of the estimators. So in this category, we also have the very popular heterogeneity estimator, that is the de Simon and Laird. So this estimator, it has been shown that it is unbiased before truncation to 0 and under the random effects assumptions. So as we mentioned, the de Simon and Laird method is the most popular estimator, and it is the default option in most meta-analytical software. However, the truncation to 0 may lead to biased results, and studies have shown that it can underestimate heterogeneity when we have only a few number of studies and the between-study heterogeneity is large. On the contrary, the Hedges and Olking method has been shown that it performs well for large heterogeneity, but it requires also, as the de Simon and Laird, a large number of studies. In general, it is not preferred, it is not recommended, as it produces large estimates. Then we have the Hartung and Maccabi method, and the authors Hartung and Maccabi selected to propose a correction to the de Simon and Laird estimator so that it doesn't need a truncation to 0 and it produces positive estimates only. So the method is more efficient than the de Simon and Laird and performs well for meta-analysis. With small and large studies, but for small to medium study sizes and small heterogeneity, it produces substantial positive bias. The Hunter and Smead method is also a modification of the de Simon and Laird estimator and uses the fixed effect weights. The method is more efficient than the de Simon and Laird and the Hedges Olking, but it has substantial negative bias. Now, the next three estimators belong to the generalized Q-based method of moments estimators, and they may include the 0 value. So we have a two-step de Simon and Laird, the two-step Hedges and Olking, and the Paul and Mandel methods. The first two methods, the two-step de Simon and Laird and two-step Hedges and Olking methods, it has been shown that they decrease bias compared to the one-step de Simon and Laird and Hedges Olking methods. And regarding the Paul and Mandel estimator, it is shown that it is equivalent to the empirical Bayes method, and it performs better than several alternatives in terms of bias. Also, it approximates better heterogeneity when it is compared to the de Simon and Laird However, simulations have shown that when a mixture of small and large studies are included in the meta-analysis, it may produce higher positive bias compared to the de Simon and Laird, the Hartung-Maccabi, and the restricted maximum likelihood methods. Then we can move on to the maximum likelihood estimators, and we can start with the maximum likelihood method, which is asymptotically efficient but has substantial negative bias. And this occurs when we have large heterogeneity and few studies in the meta-analysis. Now, in order to correct for the negative bias associated with the maximum likelihood method, the restricted maximum likelihood method has been suggested. For dichotomous data, it is suggested that for small heterogeneity and small number of studies, the restricted maximum likelihood is less efficient than the de Simon and Laird, but for continuous data, its efficiency is comparable to the de Simon and Laird. Also, the restricted maximum likelihood is more efficient than the Hedges-Olking, but less efficient than the maximum likelihood and Hunter-Smith. Its mean squared error is comparable to the Hartung-Maccabi and the two-step de Simon and Laird. Also, it has been suggested an approximation of the restricted maximum likelihood in order to adjust for the loss of degrees of freedom, but studies show that this method yields almost the same results with the restricted maximum likelihood. Then we have the Siding and Jonkman method that typically produces among the highest estimates of heterogeneity, irrespective of the type of data, either if they are continuous or dichotomous, and the estimator is a positive estimator and a direct method. Now, studies show that it is associated with small bias and small mean square error for large heterogeneity, but it has large positive bias and large mean square error when we have small to moderate heterogeneity. Then we have the Bayes estimators. These include three methods: the Bayes model, the Rooking Bayes, and the fully Bayesian approaches. The methods yield always positive values, and they all are iterative approaches. Although the Bayes model is more efficient than the de Simon and Laird restricted maximum likelihood, it is associated with large positive bias when we have a small heterogeneity and especially small number of studies in the meta-analysis. The Rooking Bayes method has lower bias compared to the de Simon and Laird when few studies are included in the meta-analysis, and the fully Bayesian approach allows for incorporation of uncertainty in all parameters, and including the heterogeneity parameter, but we need to be cautious as the choice of prior is crucial, especially when the number of studies is small. Finally, we have the bootstrap methods, and in particular the non-parametric bootstrap de Simon and Laird that we have encountered in our lit review. The method is associated with lower bias than the de Simon and Laird when the number of studies is larger than 5. Otherwise, simulations show that it has greater bias than the de Simon and Laird. However, the advantage of this method is that it identifies better the presence of heterogeneity when we have only a few number of studies in the meta-analysis, and this is a concern that has been raised for the de Simon and Laird method, that it cannot really identify the presence of heterogeneity when it truly exists. Now, in this slide, I provide the estimated results regarding the between-study variance using the identified methods in 4 different meta-analyses. The first meta-analysis has a low heterogeneity. Then we have a very low heterogeneity according to the R-square, moderate and high heterogeneity. So I highlight in green the lowest estimated heterogeneity value, and in red, the highest estimated heterogeneity value. As you can see, the estimated heterogeneity value can considerably vary among the methods. For example, in the first example with the 14 studies and the I-square that is equal to 0%, where we have low heterogeneity, the estimated between study variance ranges between 0 and 0.15. So we need more guidance on which method is most appropriate in its case. So in summary, the methods vary depending on their properties, as you can see, and there is no uniformly best approach for all meta-analytical scenarios. The software that we can apply the methods are several, and as you can see, the most popular is the Dersimonen and Laird, and this is followed by the maximum likelihood and the restricted maximum likelihood methods. Before I continue, I would like to hear your preference in the software to conduct a meta-analysis. So maybe we can again start a poll and see which software you prefer to conduct your meta-analysis. Great, so most of you use Review Manager, and many of you also use Stata and R. So the good news for Stata and R is that they have several routines and packages that we can apply most of those methods that we have seen. But so far, Review Manager has only one, that is a Dersimonen and Laird, and this is what we are currently discussing to add more methods to estimate the between study variance. But as we already discussed, you have to, even if you're using Revman, you have to explore whether the Dersimonen and Laird is the best option for your meta-analysis. So just to clarify, our initial aim was to conduct this review, discuss among the best alternative options, and then recommend better options, if there are any, to be included in Revman. And before we make any inference on the choice of other estimation alternatives, we need to understand which are the main factors that may affect the between study variance estimation. And these, according to the published studies, may include the number and the size of the studies that we have in a meta-analysis, the magnitude of heterogeneity, the distribution of the true treatment effects, the type of data, the effect measure that we use, the frequency of events if we have dichotomous data, and how well the study-specific weights, variances, and treatment effects are estimated, since we usually assume that these are known. So, an empirical study using around 60,000 Cochrane meta-analysis has shown that heterogeneity fails to be detected and is generally higher than what it is assumed. So we need alternative methods to estimate heterogeneity, to better estimate heterogeneity. The majority of the pairwise meta-analysis include fewer than 10 studies and a small between study variance, according to empirical studies. So in the next few slides, we will summarize the results for all the non-Bayesian estimators, and we select this because Bayesian estimators have not been evaluated extensively in the comparative studies. So in the most common meta-analytical scenario, simulations suggest that the Dersimonen and Laird underestimate heterogeneity, especially for rare events. Although the positive Dersimonen and Laird and Hartung-Maccabi may have good coverage for the overall effect size, they can overestimate heterogeneity. Similarly, the positive Rookin-Bayes, the Bayes model, and the Siding-Jonkman methods overestimate heterogeneity, but the Bayes model performs worse than the Dersimonen and Laird when we have zero heterogeneity, and the Hedges-Olking and Siding-Jonkman methods are less efficient and exhibit higher bias than the Dersimonen and Laird. So in that question, should we implement any of these methods in Revman? We would probably say no, taking into account these study results in the specific case. On the other hand, Hunter-Smith and maximum likelihood methods have substantially negative bias, and also the bootstrap testimonial and Laird has good coverage for the overall effect size, but it is associated with higher bias. The two-step Dersimonian and Laird and Hedges-Olkin methods approximate the Paul and Mandel method and have similar properties, but for rare events they can underestimate heterogeneity. The restricted maximum likelihood method is less downwardly biased than the Dersimonian and Laird and maximum likelihood methods, and it is recommended for continuous data, but it has greater mean square error. Also, and the approximated restricted maximum likelihood, as we said, it yields almost identical results with the restricted maximum likelihood. So in the question, should we implement any of these methods in Revman, we would probably say no to Hunter-Smith, maximum likelihood, and bootstrap Dersimonian and Laird. We would probably add a question mark to the two-step Dersimonian and Laird and Hedges-Olkin methods, and we would probably say yes to the restricted maximum likelihood and its approximation, considering the specific study results. Although the Paul and Mandel method is positively biased, when study sizes differ importantly in a meta-analysis, simulations have shown that it outperforms both Dersimonian and Laird and restricted maximum likelihood methods, among others, in terms of bias for both continuous and dichotomous data. However, we need to consider that it is rarely appropriate to rely on one between study variance method when we only have a few number of studies in the meta-analysis, and especially when these studies are small and we have rare events. So in the question, should we implement Paul and Mandel estimator in Revman, we could probably say yes, considering again the specific study results. Now, in order to fully estimate the between-study variance, apart from the point estimate, we can also calculate the uncertainty around the between-study variance. So the properties that we need to account for, the desirable properties, are accuracy, and precision. So we need accuracy, that is the high coverage probability, and precision to have narrow confidence intervals. Now, different methods to calculate a confidence interval may suggest different results. So here again, you can see the results of the different confidence interval methods for calculating the uncertainty for the between-study variance using the same 4 examples that we used in a previous slide. So having a closer look at these 4 examples across all these methods, you may notice that most of the confidence interval methods differ in the width, and some of them, in some cases, may even not overlap. So again, we need to we need to choose which of these methods would probably be the best to use. And as we already discussed, there are 9 confidence interval methods that we categorized in 6 broader categories. Most of those methods have been compared in studies, and these studies used mainly coverage to assess those studies, and only a few of them used precision. So I will present the results using a summary of these studies results. Simulations showed that the bootstrap confidence intervals have poor coverage, whereas the profile likelihood and the wall-type methods require a large number of studies to perform well. The Siddick-Jonkman, similarly to the the estimator of the heterogeneity, performs well only when the between study variance is large. And the Q-profile method is preferable to all the aforementioned methods as it retains coverage even when we have only a small number of studies in the meta-analysis. Then the Biggerstaff and Jackson and Q-profile methods can provide narrow confidence intervals, so we can say that these are precise, but we need to be careful because both can result in the null sets, in empty sets. The Q-profile method performs better for large between study variance, whereas for small heterogeneity, the Biggerstaff and Jackson is preferred, and for moderate heterogeneity, the Jackson method is recommended using the weights equal to the inverse of the within study standard errors. Now, among the three, the Q-profile method is the simplest to compute. Now, in this table, you can see all the approaches to estimate the uncertainty and estimators for the between study variance. So with TIC, I present the methods that are based on the same statistical principle and can be naturally paired. With TIC in a parenthesis, those that could in principle be paired but not naturally, and with dash line, those that are unlikely to be considered that are compatible. Therefore, as you can see, not all of those methods, the confidence intervals, are appropriate to be used for all the heterogeneity estimators. And what we suggest is using only methods based on the same statistical principle that can be naturally paired. And this is because using this approach, we may avoid issues such as confidence intervals not containing the heterogeneity estimated value.